So this is lesson 3.5a in elementary algebra, slope in the equation of a line. And we're talking about the slope of a line. What we're actually talking about is how steep the line is. And the steepness of the line, the steeper the line, the bigger the slope will be. So if we have a slope that is horizontal, the slope is, if we have a line that's horizontal, the slope is going to be 0. And we use the letter M to represent slope. I have no idea why, but if it's at a horizontal line, it's 0. As it gets steeper and steeper and steeper and steeper, that line, or that slope, gets to be a bigger and bigger and bigger number until we get to where it's straight up and down. And when the slope is straight up and down, it's like falling off a cliff. There is no slope. So on a vertical line like the y-axis, the slope doesn't exist. It's called the null set. Put a circle with a line through it, meaning there is no answer to it when you have a slope that's vertical. So now what we have is we have a whole bunch of numbers in between, depending on whether the slope is horizontal to straight up and down. Now if it goes past straight up and down, for example, if it goes, instead of going this way, it goes this way, we have what's called a negative slope. And it's the same way. As this becomes less and less negative, it'll eventually go to 0 and then start going positive. But if it's vertical, it doesn't matter if we went from a negative direction or a positive direction. The slope of a negative or of a vertical line will always not exist. Alright, so where do we get the number for the slope? The formula for the slope is how far up or down we went and how far left or right we went. It's always y over x. So it's the vertical change, this part right there, that's your y when you're looking at the xy axis, and our horizontal change, our x. So what we've got here is, let's say that we have a slope, or we have 2 points. We have this point right here, and let's say that that point is over 8 up 6. And let's say that this point is over 1 and up 2. And we're trying to find the slope. Well, I said the slope was y over x. But if you look here, I have two different y's. I have this y and this y. Which one is the slope? I have two different x's. The 1 and the 8 are both x's. So how do I find the slope? Well, I take one of my y values and my other y value, and I write them like this. One of the y's minus the other y over one of the x's minus the other x. Alright, so I have it written here as one of the x's as x1 minus x2, y1 minus y2. The book has it y2 minus y1. It doesn't matter. All these symbols mean, this just means one of the y's, this means the other one. Doesn't matter if you name them 1 or 2 or 2 to 1 or Peter and Paul. As long as you know which y you're talking about, it doesn't matter. So let's do that. Let's take one of my y values. Okay. So one of my y values is, well, let's take the one on the left, 2. Minus the other y value, 6, over. Now because we used this 2 as our y1, we have to use this one here as our x1. That's the only thing that has to be true. 1 minus my other x is is 8. So 2 minus 6 is negative 4. 1 minus 8 is negative 7. Two negatives make a positive, giving us a slope of 4 over 7. So that means that if we start right here, if that's one of our points, to find the next one, we go up, or we do our y, we go up 4 and over 7, and we'll end up here. If we go up 4 and over 7 again, we'll find another point that will be on this line. We just connect our dots if we're graphing it, and that will give us the line that go through these 2 points, but all we're really concerned with is the slope. So let's do this on another problem without drawing a graph. So example 1 says find the slope of a line through 1, 2, and 3, 5. So what we're looking at is a slope, and the slope equals 1, the difference of the y's, over the difference of the x's. So let's take the y's and subtract them. 2 minus 3, and the y's, oops, sorry about that, not 2 minus 3, should be 2 minus 5, my y's, and then 1 minus 3. And that gives me negative 3 over negative 2, which equals 3 halves, 2 negatives. Alright, let's say that we did it the other way. Let's say that we picked different y's. Let's say that we picked the 5 to be our y first, and our 2 to be our y second, and then our 3 to be our x, and our 1 to be our x2. Now what do we get? 3 over 2. Notice I get the same thing. So it doesn't matter what order you do these in. It never matters. So that means if we were to graph this, we would start at one of these 2 points. Let's start at 1, 2. So start there. Alright, to find my next point, I would use my slope, and I would go up 1, 2, 3. So now I'm up here, and I'm going to go over 2. So I'm going to start here, and I'm going to go up 3 and over 2, and that would give me that point. To get my next point, I would go up 3, over 2, and get that point. And if I do, it doesn't matter how far I go, I'm going to get a straight line. Okay, so let's look at example 2. We have a negative 2, 1, and we also have a 5, negative 4. And if we use our same, I'm going to switch those around just to show that it doesn't really matter what order you put those in, as long as your 2's are first and your y's are second, or vice versa. Alright, so let's do our y's. 1 minus negative 4 over negative 2 minus 5. So 2 negatives give me a positive, so that's really 1 plus 4. This is going to be a plus negative, so the signs are the same. I'm going to add and put the sign on there, and I get negative 5 over 7, or 5 over negative 7. Now that doesn't matter, again, where the negative sign is. I can put the negative sign here or up there. It doesn't matter. So let me show you. Let's graph this. So we're going to graph one of the points. One of the points they gave us was negative 2, 1 in the problem. So we're going to start at that point. So negative 2, 1 is right here. And then it says what we have here for our slope is 5, negative 7. So that means we're going to go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So one of our points is there. What if we change this to negative 5 over negative 5 over 7? Let's see how that changes things. Let's do this in green here. So negative 5 means we go 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 5, 6, 7 over. Alright, so we get a different point, but what we're trying to find out is the graph of that line. Notice the graph of the line is not going to change. We either put this point through this point, draw a straight line, or this one and this one and draw a straight line. But notice we get the same straight line no matter what direction we go. So it doesn't matter whether the 5 is negative or the 7 is negative in this. Alright, so let's look at example 3. So example 3 says graph the line with a slope of 3/2 and a y-intercept of 1. Okay, so let's bring our graph up. And it's saying that my y-intercept is 1. That means it crosses the y-axis at y equals 1, 1 up. So there's 1 point. It also says that my slope is 3/2, and remember my slope is y over x. So there's 1 point we're going to start with, and it says that the first number, 3, is a y. So we're going to go up 3, 1, 2, 1, 2, 3, and then we're going to go over 2. And we end up with a point there. And then if we want, we can go up 3 and over 2 again to get another point. You can do that as long as you want. But when you connect your dots, you're going to get a line that looks like that. And that slope, whenever you have a slope and it goes uphill, that means it's a positive slope. And here, over here on our slope, 3/2, it's a positive number. If our slope went this way, it would be a negative slope. We would be going downhill. So let's jump over to example 4, and we'll start that on the next video.